I'm Allison Parrish, and this is my talk for PROCJAM 2015. It's called Speaking Terms, A Few Thoughts on Verbalizing the Semantic Web. It's really an honor to be asked to speak at PROCJAM, and I'm super grateful to the organizers for the opportunity. Since this is a pre-recorded remote talk, I figured I'd include a picture here of what it looks like when I'm actually speaking in front of an audience. This is a picture of me speaking at IndieCade East earlier this year. I'm the one in the corner, and that's a big picture of Noah Webster on my projector, in case you're looking. To begin, a little bit about me. I'm a poet, computer programmer, and an artist. I live in Brooklyn. I am currently the digital creative writer in residence at Fordham University, where I teach computer programming classes about hypertext and procedural poetry to unsuspecting creative writing undergraduates. I'm also an adjunct professor at NYU, and I'm wrapping up teaching a class at the School for Poetic Computation, which is here in New York City. So the subject of this talk, what I want to talk about today, is a particular database called ConceptNet, which I've been using for generating creative and poetic text. ConceptNet is a semantic database with common sense knowledge in it, or at least that's the purpose. And this diagram kind of shows what the data in ConceptNet looks like. And we'll talk more about this exact structure later. ConceptNet is great, and I love it, and it's kind of wonderful to use. But for the reasons that I'm using it, poses a number of challenges, and I believe those challenges are interesting to talk about in the context of procedural generation in general. I'm still gathering my thoughts about this, so this is kind of an experimental talk. So I'm just kind of throwing a bunch of things together and seeing if they stick, and I hope that the talk is useful to you. So you might be asking, why is a poet talking at a game jam? What is the deal with that? I actually think that procedural game generation, procedural poetry generation have a lot in common. Writing a poem is a lot like designing a game, in my opinion at least. Both reading a poetic text and playing a game are activities that are governed by rules and conventions. And both game designers and poets are essentially attempting to design an experience for the reader or player that happens within that set of rules. They're both trying to essentially choreograph the movement and attention of the player or reader. People who create procedural content for games and people who write programs to compose text also share a lot of the same computational techniques. So I think there's a useful dialogue to have here, and I guess the PROCJAM organizers agree. I kind of find like the idea of a text being sort of similar to the idea of a game as a whole. Writing a poem is kind of like doing level design. A game mechanic is sort of like a poetic form. Like they're both ways to organize and to communicate rules about how a particular piece of media is supposed to be used to the player or the reader. And then graphics are the graphics of the game are sort of like the style of the poem. It's like an aesthetic layer that sits on top of the form, but also deeply permeates and informs it. So before I get started on the main content of the talk, I want to talk a tiny bit about some of the projects that I've been working on. I just said that I'm a poet, but I do also actually make games. The games that I design primarily have to do with words and spelling. So this is a trailer for Excavator. I should have turned down the volume on that first. This is a video game that I made a few years ago that works kind of like playing Boggle and Super Mario Brothers at the same time. Unlike most other word games, Excavator takes into account English lexical information beyond single letter frequencies, meaning that letters that are more likely to co-occur in English words are more likely to appear next to each other on the board. If you're familiar with Markov chains, that's kind of essentially the procedure that I'm using to generate the position of the letters on the board. My goal with this game was to create a word game that naturally produces longer, meatier, more satisfying words. Most of my practice right now is focused on Twitter bots, specifically on bots that produce text. Probably my best known bot is Everyword, which is a bot that I made in late 2007. Its mission was to tweet every word in the English language in alphabetical order, one at a time, every 30 minutes. It completed its task last year in early June 2014. When it tweeted its last word, it had over 100,000 followers, which isn't that much compared to like a member of One Direction, but that's a pretty big audience for a work of conceptual writing. The story that I usually like to tell about every word is that when every word was coming to an end, it was in alphabetical order, so everybody was guessing about what the final word would be. So I want to show you what happened at the end, because I think it's sort of germane to procedural generation as a topic. And especially because a lot of people were surprised by what did happen. So the bot tweeted zymotic, and then right after that it tweeted zymergy. And at this point, a lot of people thought it was over. Like, there were a lot of like responses to this saying, like, "Congratulations, every word, you did such a good job." But then, after that, it tweeted eclair. I don't know why it tweeted eclair. If you're a computer programmer, then you probably have some inkling of why this is the case, and that's because the text file that I used was encoded in Windows 1252 encoding. I don't remember where I got that text file, but whoever originally created it obviously sorted the file with a tool that didn't recognize that an E with an accent is usually collated with a regular E in English when we do alphabetical sorting. All it knew is that the value for E in this encoding, which is 233, is greater than the value for Z, which is 122, and so eclair is supposed to come after zymergy. So this was like super surprising to most of the people that followed every word, and that occasioned what I think is is worse even than the end of worst ebooks. This is probably the best review of my work ever, and it's a confirmation of what I firmly believe, which is that computers are weird. And when you make them do things with words, they do surprising, sometimes shocking, sometimes unintuitive things. And that makes computers a great tool for writing poetry. So slightly moving back to the topic of procedural generation and concept net, I want to talk about my project for last year's National Novel Generation Month. National Novel Generation Month, or NaNoGenMo, is a yearly event organized by Darius Kazemi, in which programmers have 1 month to write a computer program that writes novels. The 2015 event is actually happening right now. Like, NaNoGenMo is November, to coincide with NaNoWriMo. So I encourage you to participate in that, in addition to PROCJAM. So the novel that I made last year is called I Waited in Clear Water, and this is an excerpt from it. I'm not going to read this or anything, I just wanted to show you what it looks like. So the main body of the text was generated by parsing, then rewriting, then reordering sentences from a book called 10,000 Dreams Interpreted. The footnotes that you see were generated by taking nouns from the main body of the text and then looking those nouns up in ConceptNet, and then generating sentences based on the information that it found in ConceptNet. So let's talk a little bit more about ConceptNet and what it is and how it works. ConceptNet is an online graph-based database that contains relations between terms. The goal of ConceptNet is to be a computer-searchable database of everyday cultural knowledge. What you're looking at here is a screenshot of what the search interface looks like, where I've looked up the word iron, and the search results show that ConceptNet knows a number of things about the term iron, that it is a metal, for example, that it has the property of being heavy, that it is found in a laundry room. And this is like one of the weird things about ConceptNet, is that it isn't very good at disambiguating different senses of the same word. It can't tell the difference between iron as a metal and iron as the household implement. So it's kind of a weird source of data. So what I use ConceptNet for in I Waited in Clear Water is I would look up random nouns in the main body of the text and find a random fact in ConceptNet about that noun. And when it finds a noun, it then takes that random fact from ConceptNet and plugs it into a sentence template. So, for example, if it gets the fact iron has property heavy, it might generate the sentence, this iron was heavy. If it gets the database record iron application laundry room, it might generate the sentence, you said it was in the laundry room, for example. Another thought, or another project that I have made recently with ConceptNet is this bot called DeepQuestionBot. DeepQuestionBot is, or the implementation of DeepQuestionBot is fairly simple. It looks up a random common sense fact on ConceptNet and then rephrases that fact as a question. So for example, ConceptNet has a relation claiming that mailboxes RNA has a relationship with mail. Like the term mailbox is related to the term mail by a has a relationship. What DeepQuestionBot does is it asks, why must that be the case? Why must mailboxes have mails? Give me a good reason. So the effect of this is kind of humorous, right? To call into question these everyday facts that are usually just considered to be common sense. So here are a few more examples. So sometimes this is, it says, what if you found an egg in a dishwasher instead of a refrigerator? So this is like an example of an unlikely situation proposed by DeepQuestionBot. DeepQuestionBot has also asked, why does a robot have to be a machine? Which is kind of like on the edge of self-awareness. And then here's DeepQuestionBot with a little bit of capitalist critique. Have you ever considered a brand that is insignificant instead of important? Which is like a sacrilegious thing to say on Twitter, of course. People have told me that DeepQuestionBot resembles either a 4-year-old or someone who is super high, which I think is kind of an aesthetic to be able to invoke with procedurally generated text. So I'm pretty happy with how these projects turned out, but you might have noticed that a lot of the text feels kind of unnatural. Now, I don't think that generative art has to feel, quote, natural for it to be successful, and in fact, quite the opposite. In my opinion, it's precisely the weird glitches in generative art that give it the character and verve and surprise that is particular to that kind of art. But I do think it's worth examining how exactly the structure of ConceptNet gives rise to these particular unnaturalnesses. And as an aside, I want to say that using ConceptNet specifically to generate English sentences is, as far as I can tell, an off-label use of ConceptNet. It's not among the original uses envisioned by the creators. And this is actually the case for a lot of the tools that I use in my work. Most natural language processing and machine learning tools are made for analyzing text, not for generating it. And as an artist and a poet, I find myself using these tools in ways that I imagine the creators never imagined, working against the affordances of the tools instead of with, which is hard sometimes, but is also what makes my work interesting and exciting. So getting back to how ConceptNet is weird, as I mentioned before, ConceptNet relates terms to each other with relations. Some of these relations are represented in this search string that I showed earlier, but there are several dozen others that are found in the database, relationships, or relations like has prerequisite, or made of, or capable of, or receives action, etc. These relations are intended to give you information about how the two terms are related. So, for example, iron is a element, means iron is a kind of element, and iron has property hard, tells you that the term iron has the property of being hard. Right? To illustrate the problems that I've had with generating text with ConceptNet, I want to focus on one particular relation that is present in the database, and that's the application relation. So to illustrate this, I want to point out that you might have noticed when I was talking about I waded in clear water and DeepQuestionBot that some of the sentences, especially the sentences having to do with physical proximity, are kind of super weird. So for example, here are some of the sentences from I waded in clear water. All of the sentences that I've highlighted in green are sentences that were generated from that application relation. So you notice here that there's a lot of like withins and a lot of like incorrect prepositions. So for example, your teller was discovered in a bank, someone was within our bank. Like you wouldn't normally describe something as being within a bank, and especially not a person, right? The carpet was discovered in a room a floor was within it. Like, saying that a floor is within a room is like a really, really weird thing to say. Like, a person wouldn't normally phrase it that way. An apple tree was in the bloom is also not something that we would say. We would say an apple tree was in bloom, right? A mouse was not in the barn, we saw it in a farm. You don't usually talk about things as being in farms, you talk about them as being on farms, right? So there's clearly like some weird stuff happening here. Like, the data is coming from ConceptNet, but the sentences that I was generating from that ConceptNet data just seem a little bit strange. Another illustration of that, here are some example tweets from DeepQuestionBot. Tweets like, why is a wall kept in a refrigerator? Why is an ocean found near an ocean? Stains are kept in rugs, but where do you find confusion? So these are like tweets that seem to be talking about physical proximity, but they are weird. They have like weird prepositions. I'm using this preposition near all the time. I'm using the phrase kept in or kept near very frequently. And I want to explain why I did this, or what it was about ConceptNet that made this the best strategy that I could find. So here's why. This is an example of a typical application entry in ConceptNet. So it's basically saying that the terms cheese and refrigerator are in an application relationship. So you might figure that you could just take the data from ConceptNet in this case and insert it into a simple sentence template like this. Like, I wanted some blank, so I looked in the blank. And you can take the term on the left of application and put it into the first blank, and take the term on the right of the application relation and put it into the second blank. So I wanted some cheese, so I looked in the refrigerator, right? That seems simple enough. But if you actually look at the ConceptNet data, and I apologize if this is like too small for you to read on the screen, but if you look at the actual ConceptNet data, you can see that the application relation apparently has a much wider semantic scope. It has a much wider range of meaning than you might have initially expected. I've just shown like a handful of the application relations for the term cheese, and we can kind of go through these one by one. Cheese, application, refrigerator makes sense. Like, you find cheese in a refrigerator. That's the location of the cheese. The second one here, cheese, application, pizza, also makes intuitive sense, right? Like, if you have a pizza, then cheese is one of the things that might be at the general location of the pizza. However, you wouldn't say, I wanted some cheese, so I looked in the pizza, unless it's like a special like stuffed crust pizza from Pizza Hut or whatever. You don't normally say that the cheese is in the pizza, you say that the cheese is on the pizza, right? And the same thing goes with cheese and plate. Those are definitely like intuitively related by an application relation. But the phrase that you would use generally in English isn't, I wanted some cheese, so I looked in the plate. It would be, I wanted some cheese, so I looked on the plate. And then the next one, cheese is at the location of dinner, is, you would still say like, or in that case, like, it's still intuitively true that yes, if you metaphorically think of a dinner as a place, cheese might be found in that location. But it would be super weird for an English speaker to say something like, I wanted some cheese, so I looked in the dinner, right? That's just kind of like an odd thing to say. And then in some cases, the data in ConceptNet is just super weird and not normalized. Some of these application relations have the preposition built in, so cheese application at supermarket is like already in the database. So there's all kinds of weird things in this database, in this ConceptNet database. And this initial sentence template that we thought would work it's actually not that complicated, or it's not that simple. We have to like find some other way of taking this data and realizing it as an English phrase. So in the end, the application relation captures an interesting conceptual similarity among all of these terms, but in the process of capturing that similarity, in the process of ConceptNet taking reality, taking language and putting it into this database, we lost the information that we needed to reassemble the language from which the relations originated. And that's not just the application relation. All of the relations in ConceptNet break down reality in ways that don't quite line up with the syntax and structure of the language that we generally use in everyday life. And that applies not just to concept map. The larger point that I want to get at here in this talk is that anytime you take language from the world and you put it into a formalism of some kind, whether it's a database or a corpus or it's data that's been compressed or marked up, whoever is making that formalism makes some decisions about what is going to be left out of the text. Now, when you're trying to create work that uses these databases to generate language, you have to engage in some creative tactics in order to reintroduce the information that was lost when the language was formalized, in order to actually take the data from the database and turn it back into language. And the diagram I have here sort of illustrates that process. You start with some language out in the real world, and then somebody puts it into a database, and in that process, some of the information about that language in context is lost. So in order to take that data and turn it back into language, you kind of have to rehydrate it with your own ingenuity, basically. And that ingenuity is what makes procedural generation, at least procedural generation of text, interesting. So this is basically a long way of explaining why I use neither so much in Deep Question Bot. My strategy for rehydrating the data from Deep Question Bot, because the application relation can't be expressed in just a sentence template that uses the word in, I use the preposition near instead. So instead of saying like, why are gazelles kept in grasses or at grasses or on grasses, I just use near to sort of like approximate the semantics of that relation as well as I could in English without creating text that plainly felt wrong. So this is a suboptimal solution in many ways, but on the other hand, this decision that I made gives the bot its unique texture. The particular strategy that I used to turn that schematized data back into language is what makes the bot unique. So here's my bloviating educational slide where I try to tie all of this up into a conclusion. What I've learned, and here's like my advice for using weird corpora when you're doing generative work, is that pre-existing databases have pre-existing biases. Every database that you come at as someone who's making procedurally generated art, you're often going to rely on databases that were made with some other purpose in mind. And that means that the result of your procedural generation process is never going to be exactly perfect. You're always going to have to exercise some creativity in turning that data back into whatever surface form you're looking to create. And finally, personally, I love leaning into that glitchiness. An easy way to create a feeling of serendipity and uncanniness is to simply let the procedure and the database shine through as much as possible. That creates things that you never intended or expected. So my philosophy is to let that disconnect between the source data and your output shine through and see what happens. So I hope that was interesting and helpful. I would love to continue this conversation and answer any questions that you might have. I put here in this slide my web address and my Twitter handle, and I also included a link to a list of my Twitter bots. Also, a quick plug, if you are interested, InStar Books has published a book version of my bot Every Word, and that includes 2,000 pages of the entire run of the bot, plus an introduction that I wrote. So go to instarBooks.com to buy a copy of that if you would like. So thank you, and break a procedurally generated leg this week in PROCJAM.
I believe Allison is actually listening on the stream. So